Another example that we're going to be looking at. Remember, once I've written it down, you should attempt the question first. 2 sine of 55 degrees multiplied by cos of 60. Cos of 60 degrees multiplied by cos of 5 degrees. Right, those 5's and those s's look the same. Okay, plus sine of 60 degrees multiplied by sine of 5 degrees. Okay, all divided by cos of 20 degrees. Okay, so let's look at the top one. Remember, guys, when you should pause the video right now, and what you should be doing is you should attempt the question. Okay, great. So I take it you've attempted the question. Some of you got the full answer, and some of you may not have done that. So anyway, let's look at this. The moment I see cos, sine, I know that's an identity for cos, right? And it's a compound angle identity for cos. So I'm going to write down exactly what I have over here. Let's just put that in blue, is equal to 2 sine, sorry, touchpad's a little bit sensitive, 2 sine of 55 degrees multiplied by this thing, which we're going to simplify into an identity now, all divided by cos of 20 degrees, right? Okay, so as you know that this is an identity, this thing over here is the identity for cos, right? And when I see a plus sign in the expansion, I know I must use a minus sign here when I'm dealing with cos. And that's going to be 60 minus 5 degrees, right? So let's simplify that further. That's equal to 2 sine of 55 degrees multiplied by cos of 55 degrees. And as you can see, that's another identity that's starting sharp, divided by cos of 20, right? 2 sine 55 cos 55 happens to be the identity from sine of 2a. So 2 sine 55 cos 55 means that the value of a over here is going to be 55. So if I put that in over here, I'm going to get the following. I'm going to get sine of 2 multiplied by 55 degrees, all divided by cos 20. Now the cos 20 should start giving you a hint, right? We've got a sine and we've got a cos, and I've got 2 sine 55. So that's going to be sine of 110 degrees divided by cos of 20 degrees, right? Now sine 110, I'm going to teach you how to simplify this. Sine 110, sine 110 degrees actually simplifies into the following. That simplifies into positive sine, because it's in the second quadrant, 180. So you've got 110 is equal to 180 degrees minus theta. Solve for theta, and that gives me 180 minus 110. And that's going to give me sine of 70 degrees, right? So this is equal to sine of 70 degrees. Sorry, that's supposed to be sine 70 degrees. Okay, so from here I can clearly see that sine 110 is exactly the same as sine 70 degrees, which is divided by cos of 20 degrees. At this point in time, you can tell me that sine 70 is the same as cos 20, because it's co-ratios, divided by cos 20, and therefore it's equal to 1. Okay, there's another way we could have changed sine 110 into cos of 20. The alternative is to say sine 110 degrees is actually equal to sine of 90 plus 20 degrees. And when you have 90 plus theta, that's defined as a coratio. And since this is in the second quadrant, the sign is going to be positive. I then use the coratio, which is cos, and I take the argument that is over here, or the parameter, theta, and I use that. So this also shows me that that's equivalent, right? I could have said it's sine 70, which is equal to cos of 20. I could also have said it's sine 110, which is equal to cos of 20, using the coratio. Okay, and that shows me that I get a solution of 1.